we have been doing some review on percents, looking at percentages at different ways, double lines, graphs, fractional, various things. And I wanted to show a few of today's work in particular. These are graphical line and fraction representatives of fractions. These are transformations, or if we know a plus b equals c, what else do we know, kind of things, right? So if we know 30% of 80, what are all the different things that are basically the equivalent? If you are using my guides in my shop, you will notice this as a number composition, where we give a composition and then we write down all the different ways or what those compositions can mean. So this was the example that I started with. 30% of 80 also means 3/10 of 80, also means 31/100 of 80, 0.3 times 80, but 80% or 30% of 80 is also 80% of 30. Like, because we're using of, which can be exchanged for the multiplication sign, given the cumulative property of multiplication, we can exchange these things, meaning that 30% of 80 is also 80% of 30. So in addition to 0.3 times 8, we can also multiply 0.8 times 3, or 80 over 100 times 30, 8/10 over 30, 4 fifths of 30, and so forth. So we have practiced doing this for some of them where we know they are fractional equivalents. So in this case, 20% is 20 over 100, or 1/5. Then we can just divide by 5. And this right here is basically 4/5 of 20. Or no, is this right here. It's multiplying 8 times 2 and then dividing by 10. Like multiplying the first two numbers and then deciding where the decimal goes based upon how many decimal places are after the decimal. So that's what we are working on here. At a lower level, this looks like number bonds. If I know that 1 plus 2 is 3, what else do I know? I know that 2 plus 1 is 3. I know that 3 minus 1 is 2. I know that 3 minus 2 is 1, and so forth. There's actually like quite a bit of transformations beyond that if you really start looking, but these are really good in providing mathematical flexible thinking when we are problem solving. What is the easiest way for us to solve a particular problem? You notice we're not doing any calculations here. We didn't do any calculations. We're just looking at transformations, and these are helping us in keeping our mind flexible so that we can think of problems in different ways, so it's easier for us to solve them.